Chapter number 6, Fluid Dynamics. If you still remember the concept of drift velocity, which we studied in grade 10. What was the drift velocity? The velocity acquired by the electrons when they are moving through a conductor opposite to electric field is called drift velocity. Is it? Same is with the terminal velocity. Since electrons, we cannot see electrons easily, we cannot see the charged particles easily. Therefore, we cannot apply the same definition to the objects that we are observing right now. So, terminal velocity. Have you ever observed in Kuwait? I didn't witness it yet, but in Pakistan, I was witnessed it so many times. The fog droplets. The fog. Who has ever observed fog? Fog droplets. They just appears to be suspended in air, is it? Yes. Although these are basically water droplets, but yet they appear to be as suspended in air. Why? This is because of this definition. You will understand. For example, let us consider this is a fog droplet. Okay? This is a fog or rain droplet, whatever. If it is having a shape, it must be having a mass, is it? You're going? Okay. Anything that we are observing right now is having a mass, is it? Ahmed? Sleepy? Anything that we are observing is having a mass. If it is having a mass, it definitely possesses some weight. And where the weight of the body acts always? Towards up or towards earth? The weight of the body is what? How to define weight? The force with which the earth attracts the body towards its center is called weight. Is it? So this is a fog droplet. It must have some weight that acts vertically downward, and the formula of weight is mg. What happens when you pull out your hand outside a window of a moving car? The air resistance will push your hand in backward direction, is it? So when this water droplet or the fog droplet is coming down, the air resistance will make it up to move upward. Means the air resistance will act against the weight, and that resistance is called as opposite force will act in upward direction, and that opposite force is called as drag force. What it called? Drag force. Now consider the motion of a paratrooper. When a paratrooper falls, when a paratrooper jumps from an airplane 10,000 feet above, he starts to fall downward. After some time, he opens his parachute. Is it? As soon as he opens his parachute, he will go upward for some seconds, these 2 seconds or 3 seconds, and then he started to come down. On his way towards the ground, the acceleration of the paratrooper started to increase. He acquired the velocity, means weight initially will appear to be increased, and at the same time air resistance tries to fill this gap and it applies some resistance. A point reaches on its way when the weight and drag force becomes equal. After some time, when he opens the parachute, he started to accelerate. After some time, he started to come towards the earth with constant velocity. Why with constant velocity? Because at this time, the weight of the paratrooper, including the parachute, will become equal to the drag force, opposite force. When this happens to any object, either it is fog droplet, either it is rain droplet, or it is the motion of a paratrooper. When these conditions occur, the object's acceleration will become 0 and the object started to fall with constant velocity. I have repeated this again and again that the acceleration of the object will be 0 if the body is moving with constant velocity. So a point reaches when drag force and the weight of the body becomes equal, the acceleration of the body becomes 0 and the body started to fall with constant velocity. This constant velocity is called as terminal velocity. Now the proper definition. When the magnitude of the drag force becomes equal to the weight of body, when the magnitude of drag force becomes equal to the weight of the body, net force acting on the body becomes 0. Then body will fall with constant velocity, and this constant velocity is called as terminal velocity. Clear? You will not find this definition on your books. If you want to write, you can write. Keep it in your mind, the easiest definition, when drag force acting on a body becomes equal to the weight, the net force becomes 0, body started to fall with constant velocity. This is called terminal velocity. ये point to point ये लिखा हुआ है why is it important to have point to point मैं हमेशा लिखता हूँ वो हाँ ये बिल्कुल Related to rocket blasting of rocket going into space means a large amount of energy to achieve escape velocity. So it means it is related to escape the Earth atmosphere and it must have yeah. Clear? So Nehal, how to define terminal velocity? When the weight of the body becomes equal to the drag force, the total net force becomes zero. The body will fall with constant velocity, and this constant velocity is called terminal velocity. Clear? Okay. The same explanation which we discussed right now. Just this, you can write in your own words. I have to draw the same. Consider a water droplet. You can also replace this word water with fog. Consider a water droplet such as that of fog. Clear? Falling vertically downward under the influence of gravity and drag force. The air drag the water droplet increasing with speed. Okay. The air drag on the water droplet increases with the speed. What does it mean? When the water droplet from the cloud starts its journey, initially it will gain velocity. As it gains velocity, the drag force will also increase. The higher the velocity, the greater will be the drag force, opposition. The droplet accelerates rapidly under the overpowering force of gravity, which pulls the droplet downward. However, the upward drag force on it increases as the speed of the droplet increases. So, आपने क्या करना है? You must have to write, or you must know from here. Consider a water droplet such as that of falling of fog vertically downward under the influence of gravity. The air drag on the water droplet increases with the speed. Till here. Okay, what I am trying to tell you. According to the formula, net force on the droplet, sum of all the forces acting on the body must be equal to zero. First condition of equilibrium. Net force. It is coming downward because of the weight, is it? Minus drag force that is acting upward. So net force will become weight minus drag force. Clear? Any questions so far? Consider the motion of water droplet falling vertically downward under the action of gravity. The drag force increases with the increasing speed of water droplet. According to the formula, the net force acting on the droplet will become weight minus drag force. And what was the formula of drag force? This we studied yesterday. It is 6 pi eta RV. Where 6 pi is constant, eta is the coefficient of viscosity, r is the radius of the object, v is the speed. So, if you look on all these factors, drag force is directly proportional. So, if speed of the body is increasing, it means drag force will increase. Clear? And vice versa. So, that is why the drag force acting on the droplet increases with the speed. According to the relation, net force is given by weight minus drag force. And what was the weight? Weight was mg minus drag force is 6 pi eta RV. Is it? What we achieved? We achieved the net force. Clear? This is the relation we studied yesterday. At terminal velocity, when the water droplet gets terminal velocity, weight of the droplet becomes equal to the drag force. Is it? So what is weight? We know that mg equals to 6 pi eta r v. So what is the name of topic? The topic name is terminal velocity. So we can find out from here, v will become mg divided by 6 pi eta r. Clear? So this is the relation for terminal velocity. You can also put a small t so that you can remember that this velocity is for terminal relation.